Hey guys. So today we're going to talk about elements, compounds, mixtures. All right. We did this a little bit in Unit 1, but we're kind of revisiting it and are refreshing ourselves before the final. Okay. Final midterm, whatever you like to call it. All right. So pure substance. This is a sample of matter that has a defined chemical and physical properties. They can either be elements, things like molecules, or just, potassium, for example, by itself. Okay. Or it can be molecules, something like O. Okay. Compounds can be anything like, H2O, which is what's here. Right? NaCl. Right? These are two different things, but they're all under the heading of a pure substance. All right? Now, elements, they cannot be separated any further into anything simpler that has the same chemical or physical composition. Okay. Yes, we've talked about in elements there are things smaller, protons, neutrons, electrons, but protons, neutrons, electrons don't have the same chemical properties as like a full carbon atom, for example. Okay. So elements are just the element. You can have, like I said, potassium. All right. You can have sodium. All right. But you can also have something from this side like O2, Cl2, all right? These are all elements too, okay? Compounds, all right? These are two or more different, big key here is different things, all right? We talked about in the last slide, elements, like Cl, there were two of them, right? They were not different, they were the same, so they're still elements. Here we have compounds, so things like water, table salt, carbon dioxide, all right? So, they're made of elements in a specific ratio, like 2 hydrogens for 1 oxygen, that are always the same. So water is always H2O, is nothing different, all right? These are the chemical formulas. They can only be separated by chemical means, not physical means. So I'd have to chemically do something that changes. I would chemically have to alter this, chemically have to alter these. I can't physically, I can't apply heat to water, all right? Because let's just say this is my little beaker of water, okay? If I apply heat to water, it just becomes steam, okay? We talked a little bit about this. This is a physical change. It's not a chemical change. It's still water, okay? It's just in steam form. So we can't change it physically. We'd have to change it chemically. All right, some common ones we should know. Table salt. Not that we actually use chalk in class anymore, but we used to. All right, CaCO3. Rust is iron oxide, or FeO. The one you probably hear a lot about is carbon dioxide. Living in Atlanta with all the driving and all the pollution, you've probably heard of carbon dioxide. Okay? Now, a mixture. Okay? This down here. All right. This is a combination of 2 or more pure substances. 2 or more pure substances. Remember, pure substances, we have elements and we have compounds. Okay, so we're mixing these up, all right? But they're not changed chemically, okay? They're not changed chemically, or they're not chemically bound up together, okay? They're held together by physical forces, not chemical forces, okay? So no chemical change takes place, all right? They can be separated physically. Okay, so in my example of my beaker of water, okay, and I have sand in my water. I can heat it. That's the worst flame ever. I can't even deal with how bad that one is. Hold on. So here's a candle, a wick, no flame going up. There we go. That ain't that much better, but. So, heats the water, water finally evaporates off, and I would just be left with a bunch of sand in the bottom of this beaker, okay? So I can separate them physically. You're not chemically bound, they're physically kind of held together. All right, we have two options when it comes to mixtures. We have a heterogeneous and a homogeneous. Sorry about that. Yes. Okay? So, in a heterogeneous mixture, substances are not evenly distributed throughout the mixture. The word here is not. Okay? Some examples: chicken noodle soup, water, all right? Oil and water is probably my favorite. You have the oil that sits on top of the water that's underneath, so we have water down here in this area, and oil that sits on top. All right, orange juice with pulp, things like this. So if I can see layers or see differences in them, that makes up a heterogeneous mixture. On the flip side, homogeneous mixtures, you also see it written as a solution, okay, are substances that are evenly distributed. And you cannot see the difference, okay? So some example: coffee, whole free OJ, okay, salt water, sugar water, blood. All these are examples of things that we can't really see layers or see the different things. It's all mixed evenly throughout. So, when we look at a little kind of flow chart we have here, we got matter at the top, all matter. We go to pure substances, okay? They can only be subdivided, the category can be subdivided into either elements, things like, in this case, helium, or a compound, in this case, water. Now, on the other side, we have mixtures, okay? Mixtures can be either heterogeneous, all right, wet sand, all right, things like that, or homogeneous, tea, coffee, all those kind of things, okay? So we can see here we got all these different compounds mixed up evenly throughout. Here we can obviously see there's not heterogeneous, there's a difference between this, and there's obvious layers, okay? So in this next part, we're just going to go through a couple of pictures, and I just want you to, pause it at the end of the picture and try to figure out if it is a element, compound, or a mixture. All right, so rocks. This would be a mixture. It's a whole bunch of different things all mixed in there. Copper, that would be an element. Jelly beans, that would be a mixture. There's a whole bunch. You can either look at it two ways. You can look at this in this picture. There's a whole bunch of jelly beans all mixed up. You can see the different jelly beans. All right, or you can look at if we were to look at like inside the jelly bean on a chemical level, there's a whole bunch of gelatin, there's sugar, there's food coloring, there's all these different things. So it is a mixture. Table sugar, that would be a compound, all right? Fructose is essentially two glucose molecules put together, so that would be a compound, but there's nothing else in there other than table sugar, so it's just a compound, it's not a mixture. Tea, all right? You can say tea either with or without sugar is still a mixture, all right? All the tea molecules from the leaves are in there, all mixed in there, so it is a mixture. Salt, that is just a compound, is pure table salt, so it's just NaCl, made up of two elements, so, and it's not a mixture, so the only option would be a compound. Neon gas, neon is on the periodic table, so it would be an element. Salad, this would be a mixture. Last but not least, pure water would be a compound. So, hope this cleared it up a little bit, and that is all.